This video is going to walk you through and talk you through how to factor a difference of squares. It is another type of factoring, and you will notice that all of your answers will start off as a binomial instead of a trinomial, and from there you will have to factor accordingly. So if we look at the top where it says review on your note taker, okay, you have two binomials on the left, and if you remember how to FOIL, I'll show you what comes out on the answer side, and then we'll talk about what that means in terms of factoring. So with FOIL, remember x times x is x squared, x times negative 4 is minus 4x, positive 4 times x is plus 4x, and 4 times negative 4 is minus 16. In these types of FOIL problems, the middle two terms, when you go to combine them together, disappear. So your answer becomes x squared minus 16. That's what your problems are going to look like. You're going to start with that binomial and have to get back to the factors that produced it. Okay, so if we look at the second one, we're going to do FOIL again. 5x times 5x is 25x squared. 5x times negative 1 is minus 5x. 1 times 5x is positive 5x. And 1 times negative 1 is negative 1. Again, looking in the middle, the 5x's disappear. So your answer is 25x squared minus 1. Okay, and then for the last one, we'll do the same process all over again. So 2a times 2a is 4a squared. 2a times negative 3b is negative 6ab. Okay, then we do positive 3b times 2a is positive 6ab. And then positive 3b times negative 3b is minus 9b squared. Okay, and again, looking in the middle, the minus 6ab and the plus 6ab go away. So your answer is 4a squared minus 9b squared. One thing that you'll notice with the reason it's called difference of squares, first of all, in math, difference means subtract. So it has to be a minus sign in between your binomial. Okay, and then when it says of squares, it's talking about perfect squares. So your front term and your back term have to be perfect squares, or you don't have the difference of squares happening. Okay, so everything that we look at as examples and problems on this page, both front and back, are going to end up somewhere along the process having a difference of squares. So the generic formula for this with a minus sign in the middle, remember that in your factors, to make a negative, you have to have a plus and a minus. A squared is made from A and A, B squared is made from B and B. So it's the exact same factor twice, but with a different sign on each side. So I'm going to go through and work out some of the problems that you see below as examples, and then we'll do a couple of the back ones. And then from there, your job is to finish the rest and then to complete the homework from there. All right, so looking at number 1, set up your two binomials. Okay, you have a minus sign in the middle, so that's good news. A squared is made from A times A. Minus sign means plus minus. And to make 4, it's 2 and 2. Okay, if you don't know what numbers make that last constant happen, you can always do the square root of that C value, and that will give you the two numbers you need. Okay, so if we go down, we'll just go down the whole left-hand side at this point. Okay, so for number 3, go with the order that it's written in. Do not try to change any orders or do anything fancy to it. It will mess you up in terms of your answer. 81 is made from 9 times 9. Square root of 81 is 9. You need a plus and a minus. X squared is made from x and x. There's nothing more to do. If you were to FOIL this back, you would get where you started. All right, number 5. Okay, there's a plus sign in the middle. All difference of squares problems have to have a minus sign in the middle. You cannot factor number 5. This is prime. Okay, if it had a minus sign, we could, but it does not, so we cannot. Okay, so be very careful with that. And your two numbers, your outside pieces, have to be perfect squares, which they are. It's just that plus sign that messed us up. Okay, for number 7, 9b squared is made from 3b times 3b. Put your plus and minus in. 100 is made from 10 and 10. There's no more you can do to that. Okay, go to number 9. Okay, and we want to break it apart. We have minus sign in the middle, so we know we can do this. 16a squared is 4a times 4a. Again, put your plus and minus. 121 is made from 11 times 11. And remember, if you didn't know that, you could square root 121 and it will tell you the 11. Okay, so please know how to get those numbers. Okay, when you go to the next one, number 11, 4h squared is made from 2h times 2h. Put your plus and minus in. 25g squared is made from 5g and 5g. Okay, and then going to number 13, when you have more than one letter, as long as both letters are perfect squares, you can still do this. Okay, so x squared y squared is x times y times x times y. So xy, xy. And then plus minus, and 1 is 1 and 1. Okay, so that's what the left side looks like in terms of examples. Go ahead and finish the right-hand side of this page. Okay, when you flip your paper over, okay, I'll go through and I'll continue to do the left side in this video, and then your job will be to finish up the right side. Okay, so when we look at number 15, okay, we see a minus sign, so we're going to go through the process and see what we can do with this. 4c squared is 2c and 2c plus and minus, but then we get to 5d squared. 5 is not a perfect square. You can't split it up. So this problem is prime. If you can't break it up because it's not perfect squares, it's still prime. If you can't factor it because there's a plus sign in the middle, it's prime. Okay, so those are the two instances where prime will occur. Now, for number 17, you notice that the power is a 6. You can split 6 up equally, so this can be factored. K to the 6 is made from k to the third times k to the third. So those are perfect squares. Do your plus and minus. 16 is made from 4 and 4. So it looks weird because it's not something you're used to seeing, but you can break up exponents higher than 2 as long as they can be divided equally. So for number 19, when we set it up, we have another power of 6, so it'll be easy to do. 121 is made from 11, so r6 is r to the third. So you have 11 r to the third and 11 r to the third. Plus and minus, 1 is made from 1 and 1. Okay, so that's what the left side of that part looks like. Those are just normal factoring problems with difference of squares. Then we get to the next part, which is going to either make or break you when it comes to this stuff. Okay, you have to get the GCF out first. If you're looking at these problems, they're binomials, they have minus signs between them, but not a single one of them has perfect squares for you to break apart. That's your big clue that you have a GCF to take out. And you want to make sure you're taking out the largest GCF, not just a common factor. All right, so again, I will do the whole left-hand side with you, and you're going to practice with the right-hand side. So for number 21, the GCF is going to be the 6. When you divide a 6 away from everybody, you end up with 4a squared minus 9b squared. That binomial is a difference of squares. Okay, it's got a minus sign, and those are two perfect squares. Your 6 stays outside of your answer. It does not go away. It is a permanent part of your answer. So 4a squared is made from 2a and 2a. You have plus and minus. 9b squared is 3b and 3b. That's the entire answer for this problem. It is longer because of the GCF, but it's exactly what you need to have. All right, so going to number 23, for 45 and 20, okay, the GCF for that is a 5, but then you also need to look for letters. GCFs, remember, can be numbers and letters. So if you look, they each have a Q. So 5Q is your GCF. When you divide everything by 5Q, you're left with 9Q squared minus 4. And both of those numbers are perfect squares, so we know we've got a difference of squares. 5Q stays in the front, and then you break apart your binomial. 9Q squared is made from 3Q and 3Q, plus and minus. 4 is 2 and 2. So that's what the answer to number 23 looks like. Okay. For number 25, okay, your numbers are 136. So in terms of looking at those are both perfect squares already, but there is a GCF sitting in them. You have to take it out. Okay, if you don't, your answer won't come out correctly enough. So there is a 4 that divides into both of them, and if you look at it, they both have a B, so you have to take a 4 and a B. When you divide that away from them, you end up with 25b squared minus 9. And those are both perfect squares that we can break up. So 4b is your GCF on the outside. And then to break up your binomial, you've got 5b and 5b, plus and minus. 9 is 3 and 3. So there's your answer for 25. Okay, looking at 27. The GCF is going to be an 8. And then they both have a y that you can take. So if I take 8y out, that leaves me with x squared minus 4y squared. Those are a difference of squares, so we can still keep going. 8y's on the outside, break it up into two smaller parts. X squared is x and x, minus becomes plus and minus. 4y squared is 2y and 2y. Okay, so hopefully you're starting to catch on to the hang of this because it's not difficult. You just have to remember your processing. For number 29, 3 is the only thing you can take out. There's no letters. So if you divide 3 out, you've got n squared minus 49. Those are both perfect squares, so keep the 3 on the outside. You're going to have n and n, plus and minus, and 49 is made from 7 and 7. So that one's a little simpler in terms of what the answer looks like. When you get to number 31, all you have is letters, but the GCF involved in these are letters. You can take an m and an n from everybody. So when you take one m and one n away, you're left with m squared minus 1. Those are still perfect squares. You still got more to do. mn stays on the outside. Make your two binomials. M squared is made from m times m, plus and minus. 1 is made from 1 and 1. That's your final answer for that one. Okay. And then for number 33, the GCF for 80 and 125 is a 5. And then if you look at it, you can take 2 n's away from everybody. So 5n squared is that GCF on the outside. Once you do that, you've got 16n squared still inside, minus 25. Those are a difference of perfect squares right there. So you're going to have to break it down a little bit more. Okay, so the two binomials we end up with are going to be 4n and 4n, plus and minus, and 25 is made from 5 and 5. Okay, so using all of these examples and what I've just talked you through, go ahead and complete the whole right-hand side of this note taker, and then complete the homework that goes along with it. We'll check from what you do in class and see if you got the hang of it, and go from there.